we were talking about the direction angles, okay? We can write a relation between them. The relation is cosine square of angle x, okay, plus cosine square of epsilon, which is 60. So plus cosine square of 60 plus cosine square of epsilon, which is also 60, okay, is equal to 1. So I can find that. So you know that cosine of 60 is 0.5, okay? So I have, so cosine square of x plus 0.5 square is 0.25 plus also 0.5 square, so plus 0.25 is equal to 1. So I did use that cosine square of x is equal to 0.5, okay? So I can deduce the value of cosine x, okay? But here I should pay attention that I have to take the negative value of cosine x or the positive value of cosine x.
Negative.
Very good. Why I should take the negative value?
Because the projection in the figure is negative.
Yes. So to know if I should take the negative value or the positive value, I should look at the sign of fx. Okay. If the sign of fx is positive, then I take cosine x positive. If fx is negative, then cosine of big X will be negative, because you know, to have a positive projection along x, the angle between f2 and x should be smaller than 90 degrees. However, to have a value of f2x negative, the angle between f2 and the x-axis should be higher than 90. And here it's clear in the figure that it's higher than 90. Sometimes in 3D, I cannot rely a lot on the figure, okay? But so what I look at is the x component sign. So here we can see that if I do this, okay, I will get that I have two possibilities for phi, plus 45 or 135 degrees. I will take the solution corresponding to negative cosine, okay, because here since fx is negative, so I can write here, since fx is negative, I will select the negative solution of cosine x. Okay, I will select the negative solution of cosine x. Okay, so I can deduce that. So cosine x is equal to minus radical of 0.5. Okay, minus radical of 0.5, which will give me, if I solve, it's equal to, it's corresponding to minus 45 degrees, or since I am expressing between 0 and 180, okay? So if you solve in the calculator, it will give you that x is minus 45, okay? But we know that we have here a certain relation, okay? So if I have my angle should be between 0 and 180. So it will be minus 45 or plus 135. Okay, plus 135. Okay. Sorry, not minus 45. Had a solution for sine, because for cosine, alpha and minus alpha will give you the same result. So the calculator will directly give you 135. Okay. For sine, if you have sine, because if you put the this is the cosine sine circle. Okay. you know that if I have cosine of an angle, so let's say this is alpha, okay? So cosine alpha is equal to cosine minus alpha, while sine is, for sine, it's the opposite, okay? However, so for cosine in the calculator, if you have a negative result, it will directly give you an angle 135, okay? However, with sine, for sine, it will give you or plus or minus, okay? So of course, I will select the value of cosine negative, and the calculator will directly give me then that it is 135 degrees, okay? Any question on this? So if we continue the problem, what we did until now, we have found the unit vector of the first force. Now, once I have epsilon, gamma, and phi, okay, how to find the unit vector of this force? So if you know all angles, if you know the three angles, gamma,
I multiply them by the magnitude of the force.
yes, but I need just the unit vector, okay? What is the unit vector? Who will tell me? Unit vector of F2.
Cosine I plus
Yes,
cosine
very good. So it's cosine, the angle with x, we name it x, نسموه phi, so as you like, okay? So it's cosine xi plus cosine epsilon y plus cosine cosine gamma z, okay, gamma k, cosine gamma k, okay? So now I know the unit vector of F1 and I know the unit vector of F2. What they want from me is to calculate theta, the angle between them. So now it's very simple. All I have to say is to say that cosine of theta is equal to unit vector of F1 dot unit vector of F2. Even you don't need magnitudes of F1 and F2. And here they gave us to us, but no need. I can just solve by doing the dot product of the unit vectors. Or I can also say that it's F1 vector dot F2 vector over magnitude of F1 times magnitude of F2. Okay, this is also another possibility. Okay, any question on this? So if we look at the solution together, so first step, we find phi and we select the value, since fx negative, we select the value of phi higher than 90 degrees. So we take cosine phi to be negative. And then once we find the angle, here in the solution, sometimes they put presentation in this way. When they put in column the results, this means that the first line of the column represents x component. So if you remember, we wrote together the components of unit vector of F1. It was along I, cosine alpha sine beta, along J, it's cosine alpha cosine beta, and along K, it was minus sine alpha, okay? While for unit vector 2, the component of unit vector along x is cosine phi, along y it's cosine epsilon, and along z it's cosine gamma. So now I do the calculation. Once I do the calculation, okay, I can say that cosine of theta is equal to, I multiply the x component of the first vector by the x component of the second. So it is 0.4 times minus 0.7. So 0.4 times minus 0.7 plus, I now multiply y component of the second by y component of the first by y component of the second. So it's plus 0.8 times 0.5, and plus at the end, I multiply the third z component by this one, so plus minus 0.5 times 0.5, okay? And since I will obtain, this will give me a negative number. Okay, since it's a negative number, then I can deduce that the resulting angle will be higher than 90. This is why the calculator will give me an angle higher than 90 equal to 100.5 degrees. Okay, any question on this? So we continue. Yeah. So we continue next time. Thank you. Bye.
Have a nice
Thank
week.
you.
Thank you,
دكتور.
doctor.
Yes.
قبل ما نسكر فيكي بليز بس ترجعي تفسري لي فكرة problem 5.
Yes, sure. Problem 5. Okay. In problem 5, you need to determine the magnitude of the projected component of F acting along BC. So what they want you to do is to project force F on BC. Okay. Whenever they ask you to project a force on a line, what should you do? You do F vector, okay, dot product unit vector of the line. So you can do unit vector of BC or unit vector of CB. So in case you do unit vector of BC, you find the projected component on oriented from B to C, okay? And in case you do dot unit vector CB, then you find the projected component on this vector. Here maybe in the figure, they can see that the projection on BC is negative, okay? Because this angle seems higher than 90. This is why they choose to project on UCB, but it's equivalent, and whatever you do is right. Because from the sign of your result, you will know if the vector is oriented from C to B or from B to C, okay? So your purpose to do the projection is to find vector F and to find unit vector of BC or C, okay? To do this, you should find these vectors. So first, for F, what do you know about F? For F, you know that its magnitude is 100, and you know that it's directed from C to D, okay? Whenever you know 2 points of a force vector, you can write that vector F vector is equal to F magnitude times unit vector of CD. So it's equal to 100, okay, times unit vector of CD. Now to find unit vector of CD, you need coordinates of C and D. So to start with, if you look at your figure, D is on y-axis. So the coordinates of D are simply 0. Now along y you have this D plus B. Okay, so D plus B will give you 8 plus 4, 12. So it's 12 and 0. Okay, now for point C also you can find the coordinates. We have found them together. So you have along x it's plus C, so it's 6. Along y it is D, so it's 4. And along Z it's minus E, so it's minus 2. Okay, once you have the coordinates of points C and D, you can find unit vector CD, because unit vector CD is simply equal to vector CD, so it's CD vector over CD magnitude. Okay, so just you have now to apply. You have CD vector is x of D minus x of C, so it's minus 6i. It's minus 6i. And y of D minus y of C, it's plus 8. Yes, it's plus 8j. Okay, and you have 0 minus minus 2, so it's plus 2k. Plus 2 along the k. Okay, now once you find the vector, to find the unit vector, you should divide by the magnitude. So it's over radical of 6 square plus 8 square plus 2 square. Okay, so now you have unit vector of CD. You multiply it by 100, you find the vector F. And to project F on BC, you should find unit vector of BC and do the dot product. That's it. Okay, you want to go more in details or it's fine?
Can you go a bit more into details if you can?
Okay, what is the main problem you have? You don't know how to do the projection of a vector on a line?
ايه يعني بس جبنا فكرة ال projection of a vector on line بلشتها أنا.
Okay. When you want to project a vector on a line, all you have to do is to find the vector first. Okay. You find the
Mhm.
vector, and then you do this vector dot product the unit vector of the line you want to project on. So here you want to project on which line? You want to project on line BC. Okay. So to project on line BC, you should do F dot product unit vector of BC. That's it. Okay. So now how to find unit vector of BC? For the unit vector, you can take or CB or BC because they didn't force you to take a certain orientation. Okay. So if you want to find unit vector of BC, you need coordinates of C. You already have coordinates of C. So what is unit vector of BC? UBC is simply equal to 6i plus 4j minus 2k.
Yes, is exactly. I
Okay,
just
and you
understood.
divide
Thank
by radical.
you. طول الفكتور.
Yes, so over radical of 6 square plus 4 square plus 2 square. Okay, and once you have all, now you have everything. Okay, all you have to do is to apply the rule to do F vector, which is you found the vector, dot product unit vector of BC. So you multiply X components together plus Y components together plus Z components together. You get the projection. Okay, and since here we choose UBC, you will get a negative result. They choose UCB, so they will get a positive result. That's it. Okay. So once you find the vectors, you do their dot product. You do the dot product of the force dot the unit vector of the line on which you want to project. Okay. Go back to the course material. We have explained how to do the projection of a vector on a line using the dot product. Okay. So you should go back to the not to the problems first. You should go back to the course material to understand well the concept, then apply this. Okay.
Thank you, Dr. عزبتك.
Welcome. Bye.